Okay. We didn't do the spirometry on the on-campus lab sections either because it involves, putting something in your mouth and breathing through this apparatus to measure lung volumes in a person. And that means taking your mask off, and we can't take our mask off. So we just talked about it in the on-campus labs as well. Okay, so we'll need to talk about, hang on a second. Oh, spam. I get a lot of spam calls. Anyway, so what you need to know, first of all, is the respiratory volumes and capacity. So I'm going to pull this up on the web and share my screen with you. Hang on a second. Oh, where is it? Oh, mm-hmm. Okay, so this, that's not really, can I just blow this up? No. Hang on a second. Can't I pull this over? Hmm. Does everybody see this this figure here?
Yes. Yes.
So, um, in class, well, when we could, in the past, when we did this lab, they said hook this person up to this BioPack thing on the computer, and they have a mouthpiece and a nose clip. And you breathe through this apparatus, and would measure volumes in milliliters. And oh wait, yeah, I should have one with. Oh, I should do this one. Yeah. So time is on the x-axis and lung volume on the y-axis. And and so we would measure, there are 4 volumes. We could measure 3 of them in a person in class. One of them would be tidal volume. And tidal volume is this thing right here. And that's just a normal, quiet breathing. It's called tidal volume. And so you have to, ask this person to try to breathe normally, with this thing stuck in their mouth. And that's usually about half a liter, 500 milliliters, is for both males and females. It's usually around there. Then they do a few tidal volumes. Then we'd ask the person to inhale as much as possible. And that's this big peak right here. And from here to here, this is called inspiratory reserve volume. And then we let them do a few more tidal volumes and then ask them, like here, to breathe out as much as possible. Push as much air out of your lungs as possible, and that's expiratory reserve volume. And we can take this little cursor on the computer and click sample here and drag, click and drag to here, and then release it, and it will tell you right on the screen, on the computer screen, how many milliliters that is. So you write down the tidal volume, and then you click from the top of tidal volume to here, and that will give you inspiratory reserve, and then you click on the bottom of a tidal volume to here, and that will give you expiratory reserve. Now, and so we get actual physical numbers for those, for the volunteer. And then the fourth volume is down here, called residual volume. It's the amount of air still in your lungs after you push as much out as you can. There's still air in there, and that's called residual volume. That volume you can't measure. So the lab just says, assume it's 1,000 milliliters or a liter for everybody. All right. Then we take these volumes, and these are all defined on pages 2 and 3 of the lab, the lab document, and then the rest of the pages 3 and 4 tells you how those things were measured on the computer. And then the data analysis page on 5 has calculating what's called minute respiratory volume. That is how many liters of gas you breathe, you pull in and out of your lungs per minute. And the way you figure it out is you multiply tidal volume times the number of breaths per minute. And usually we breathe about 12 times per minute. And so 12 times about half a liter is like 6 liters. So every minute you pull 6 liters of gas in and out of your lungs. Okay. Then on page 5, you figure out the capacities for this person. And here are the 4 capacities. Inspiratory capacity, that is tidal volume plus inspiratory reserve volume is inspiratory capacity. Then expiratory reserve volume and residual volume is called functional residual capacity. Then inspiratory reserve volume, tidal volume, and expiratory reserve volume is called vital capacity. And then all of them, including residual volume, is called total lung capacity. So you're going to have to know these for the quiz, which might be in a couple of weeks also. So here's the problem. We're going to have 2 quizzes, respiratory anatomy and this one. We'll work it out somehow. But you're going to need to know these lung volumes and these lung capacities. So if I asked you what they were on a quiz, you could tell me. If I give you numbers, like I say, tidal volume is so much, is half a liter. Inspiratory reserve volume is 2.5 liters. What's inspiratory capacity? You add those 2 together to get 3 liters. See what I mean? So you need to be able to know these and be able to add the volumes together to get these capacities. You also, but I could also give you this very figure here and ask you to figure out from there. For example, what is functional residual capacity on this graph? Well, there it is right there. Just go across like this, and it's about 2 1/3, almost 2.5 liters. What would be inspiratory capacity? Well, from here up, that's 3.5 to 5.5. So let's say it's 2 liters. No, wait. 1, 2, or 3.5 liters. Like inspiratory reserve about 3.5 liters. So on and so forth. So you should be able to figure it out from this graph also. All right? Is that clear, everybody? Okay, then the next page on 6 is calculating theoretic vital capacity. And this is, so you need to know what things affect vital capacity. And there's basically 3 things that affect it in different people. And that is one, your gender. Males have a larger vital capacity than females. Two, the second factor is your age. The older you are, the smaller your vital capacity. And that's because your lungs become less elastic. Well, everything becomes less elastic with age. And so elasticity allows you to expand your lungs. And if they become less elastic, you can't expand as much and vital capacity goes down. And then finally, your height or your size is important because obviously bigger people have bigger thoracic cavities and therefore will have a bigger vital capacity. So you have these formula here. And I'm not going to ask you to memorize these formula or give you these formulas on the quiz, but you should know that you put in height, age, and gender, and you come up with a predicted vital capacity for a person of that gender, of that age, and of that height. So when you use the gender, the age, and height of the subject, of the volunteer from the class, and plug it into those formula, and get what an average person of that gender, height, and age would have for vital capacity. And then you put that in the denominator, and you put the observed vital capacity, the one you actually measured in the person, in the numerator. You divide into that and multiply by 100 to find out what percent vital capacity does this individual have compared to an average person of that gender, height, and age. And if it's exactly the same, it would be 100%. If that person has a slightly larger vital capacity than a theoretical person with those characteristics, then it'd be over 100%. If it's less, then it'd be less than 100%. See what I mean?
Hey, Professor, do you have like some sort of worksheet or study guide for this?
Well, that's what I'm talking. That's what I'm looking at right here. The
Where's that? Where can we get? Where's that at?
oh, you don't even know. It should be right there in D2L. Let me pull up D2L for you. Hang on.
What? Okay, I don't see it.
Well, let me find it for you.
Is it like the spirometry one?
Yeah, it's spirometry. It should be under
It's
content. I think it's in the lecture portion. Content,
Oh, it's sure.
respiratory system, and it's spirometry.
Yeah.
I was looking in the lab section.
Oh yeah, I'm sorry. I thought I should put it in the lab section. It's in the lecture section actually.
Okay. Wait, I still don't see it.
Let me share my screen with you, and I'll show you where. There's my respiratory system in Biotool.
Oh, okay. Respiratory. Okay, I found it.
Yeah, okay.
Oh, it's in the lab too, I think.
Maybe it is in the lab. I'm not sure, but I know it's in the lecture section. This is the lecture section right here.
Yeah,
So
they're in
this-
both.
Okay, so it's the Word document one?
Yeah, this one right here, Word document spirometry. I want to get into later on Act 5, but also there's a new one, Group Activity 5A. I added a couple questions to Group Activity 5. That
Okay.
one's brand new.
Okay.
We'll talk about that in a bit. Anyway, so let me go back to. So I'm going to go over the dispatching on the pre-lab exercise that has to do with these volumes and capacities. Match the following terms with the appropriate definition. So, volume of air taken into the lungs to acquire inspiration would be tidal volume. And in that matching it, that's G. Second one, volume of air taken in following a normal quiet inspiration, which would be inspiratory reserve volume right there. And that's D. The inspiratory reserve, tidal, and expiratory reserve altogether is vital capacity. That's I. Amount of air left in the lungs following forced expiration would be residual volume, F. Tidal volume and inspiratory reserve volume is inspiratory capacity, C. Volume of air that can be expired following a normal quiet expiration is expiratory reserve volume, A. Now here's number 7 is a different volume we haven't even mentioned yet. And we don't really just deal with it much because it doesn't exist in a living healthy person. And that is amount of air left in the lungs even if the thoracic cavity is open. So this is either in a dead person or a person with a punctured lung, a collapsed lung, atelectasis. Because remember about these pressures, atmospheric pressure, intrapulmonary pressure, interpleural pressure. Interpleural pressure is always lower than atmospheric and always lower than intrapulmonary pressure. And this means that your lungs are plastered against the inside of your thoracic cavity. So when you expand your thoracic cavity, the lungs go with the expansion and suck air into your lungs by Boyle's law. If you puncture that thoracic cavity, then you make interpleural pressure the same as atmospheric, and the lungs collapse and won't expand. If you try to expand your thoracic cavity, it won't expand with it. So then what has to be done is that you have to go in there and suck that air out and patch up that hole in order for you to breathe through that lung again. So that's called minimal volume, E. Then 8, residual volume and expiratory reserve volume is functional residual capacity. And finally 9, all of them together is total lung capacity. Okay, so we got that. Then on page 8, it would just be the numbers, the measurement of the person's volume that we measured. And notice the normal values for tidal volume is the same for males and females, but males, inspiratory reserve and expiratory reserve are both larger in males. Residual volume assumed to be 1 liter. And then you measure the capacities for this person. And again, they're all higher for males. And then you put down percent of predicted vital capacity for that person. And then the 2 questions on that page are pretty easy. Why does predicted vital capacity vary with height? Well, because if you're a larger person, you have a larger thoracic cavity. So you're gonna have a higher vital capacity. But then 6 is interesting. How would the vital capacity change if data were collected after vigorous exercise? You think exercise is going to change your vital capacity?
Yes.
Well, if I said, how does it affect tidal volume? then there'd be an effect. You'd probably be breathing more deeply, heavily after exercise. That would just mean you inspire to reserve volumes less. Actually, these volumes are just dependent upon age, gender, and size. It got nothing to do with whether you're exercising or not. Those volumes are always going to be the same. Vital capacity will always be the same. You might increase your tidal volume if you go for a run or something, but vital capacity is not going to change. Okay. Now, page 9, they have a couple of other measurements which we didn't do in lab, even if we did do the physical duty spirometry. At forced expiratory volume, percent of vital capacity can be expelled in a certain period of time. For example, the percent of vital capacity blown out in 1 second gives you an idea of how well you can exhale. The maximum voluntary ventilation, maximum amount of air that can be taken in and out of your lungs in 1 minute. Then it gets into a little pathology here. And I'm not going to get into the pathology on the quiz, but it's important to know something about a couple of lung diseases: chronic obstructive pulmonary disease, obstruction or narrowing in the airway. Well, and then chronic obstructive pulmonary disease, lung elasticity is decreased. But the actual diseases, emphysema, considered COPD. It's because of they have well, they're probably getting oxygen in, but the biggest problem is getting CO2 out. They have real trouble exhaling. Their alveoli have broken down, and it becomes fewer in number. But larger alveoli, the fewer in number, and what this does is it cuts down on the surface area for gas exchange. And they got a real problem exhaling. And sometimes they have to use forced exhalation, and it really tires you out. Because remember, in inhalation, active process, I'm contracting muscles to do that. But exhaling is a completely passive process. You're just relaxing muscles. But with a person with emphysema, they often have to use forced exhalation to push air out of their lungs. And that is active. So you have to be contracting muscles both inhaling and exhaling. And it can become pretty tiring after a while. And then pulmonary fibrosis. This is where elastic tissue becomes replaced with scar tissue or connective tissue, which doesn't expand. And you have real trouble expanding your lungs. And this means these people have the opposite problem. They got a real trouble inhaling rather than exhaling. So that's what we got to know for the quiz on this one. And this one's not going to be practical questions. It's going to be just short answer questions dealing with these volumes, capacities, or what affects vital capacity and how you figure that out, and so on and so forth. Anybody have any questions as to the quiz on this?
The only question I have is when we actually get to take the quiz, would it be okay if you, if possible, that we have a class nearby that date? Could you give us another rundown, just like a refresher on it?
Oh, yeah, and go over it again, even if it's delayed?
Yeah, because I'm with coronavirus and everything, I'm not super comfortable coming in.
I can't hear you.
I said with the coronavirus, I'm not very comfortable coming in.
Well, yeah, that's what I'm saying. You're a lot of people of you are in this section because you don't want to get into a room with a bunch of people. So it looks like we'll just have to delay this, and I can go over with you later on if if you're taking a couple of weeks or something like this.
Yeah, that would be really nice.
Yeah, that would be that'd be okay.
Thank you.
Okay, so what I'd like to do now is attack. If you haven't done group activity 5 yet and 5A, it'd be good for us to get together and do that. So does everybody have a copy of group activity 5? Because people have been turning it in individually, and that's all right. But these are really supposed to be done in groups. I designed them to be done in groups, and so I like to people to get together in groups and do it. So,
Professor, is that last week's you talking about?
yeah, the one we handed out last week, the group activity 5.
There's a 5 and a 5A now, is what
Yeah,
you're saying.
the 5A is I added to it because remember we didn't do a group activity 3, so I wanted to make up a little bit of the
Right.
points. And so in respiratory system is one that we can get a lot of interesting questions. So I put another couple of questions up in 5A. So I'm going to put you in breakout rooms again. And you guys can, so make four breakout rooms will be or three breakout rooms. Three breakout rooms would be 4 each, and one would have 5. All right, 3 breakout rooms. Otherwise, should be
You said it's 5A or just 5?
I added 5A, yeah.
Okay, so there isn't a 5 or there is a 5?
Oh, there is a 5 and there's a 5A.
Okay, so which one are we doing now, the 5A?
Well, if you've already done the 5, yeah. But
okay.
Has everybody finished 5?
No, we didn't turn it in, Professor, yet.
Well,
when
I
do
don't
you want it in?
turn it in, but you've done it already.
Oh,
yes.
Nice.
Some of us.
Oh, okay. Well then, all right, people that have done it then can go into a room and do 5A. If you haven't done 5 yet, you should go into a room where they're doing 5. And if you've already done 5 and just haven't turned it in yet, then get a copy of 5A and do 5A. That shouldn't take it too long. It's only 2 questions.
It's 2 questions.
Dr. Murphy,
Yeah.
can you please put Thelma and I and Joel in a room,
Okay.
please? Or if you're done, not until you're done, but.
Oh yeah. I'm ready to do breakout rooms right now. So.
Oh yeah, I was just reminding you.
Okay. Yeah. You'll be done once you have more questions. Once you have the group activities done, we're done for this session. So let me click on the breakout rooms. I guess I'll make 4 breakout rooms.
Dr. Murphy,
Yeah.
Can you put me, Mercedes, and the iPhone in a group, please?
Okay, let me first.
Me too. I want to
Okay.
get in with you, Kayla.
Okay, I'm gonna do it manually. Hang on a second. Great rooms. Um, okay. So Christina, Joel,
Thelma.
and Thelma in one room. Okay, and that's room 1. Okay, in room 2, who said? Oh, iPhone.
Kayla, Emma, iPhone.
No, it's Brianna.
Oh shoot! I thought you were
Mercedes.
Kayla.
Okay, so you want Brenna, Emma, iPhone, and Kayla in one.
Wait, no. I'm
No,
You need Mercedes. I mean, we can all be in a group, it's fine, but we need Mercedes too. If you can add that many in a group, it doesn't matter.
I can put Mercedes. Yeah, I can put Mercedes. Where do you want to be in there with Rihanna too?
yeah.
But yeah,
Okay, I can put 5 in the room.
okay.
And then the last one is everybody left Fatima, Lena, Melissa. There's 2 Melissas in in room 4. So I'm going to open up the rooms now. Actually, there's only, yes, 3 rooms. Okay. What's happening here? How come you're not going to a room?